Welcome back everyone. Welcome to our class. Today, we will be talking about the processes and landforms along plate boundaries. The most essential learning competency that will be covered is to explain the different processes that occur along the plate boundaries. I am your science teacher, Sir Roy M. Kapul. So let us start. Here are the learning objectives for the day. At the end of this video lesson, students should be able to explain the different processes that occur along the plate boundaries and name the landforms produced in each type of plate boundary. Which type of plate boundary is illustrated in each of the following figures below? Let us try the first one. This is a convergent plate boundary. And the clue word for this one is colliding, because the two plates are moving towards each other or they are colliding. The second illustration is divergent plate boundary. So in this particular type of boundary, the clue word is dividing. As we can see in the figure, the two plates are moving apart from one another. And the last figure, this is transform fault boundary. As you can see in the illustration, the two plates are sliding away from each other. So these are the three types of plate boundaries: the convergent, divergent, and transform fault boundary. Let us go deeper with our discussion. The convergent plate boundary can be divided into three types: the convergence between oceanic and oceanic plate, convergence between oceanic and continental, or the convergence between continental to continental plate. When plates converge, they do so in one of the three settings. Oceanic plates collide with each other, forming oceanic-oceanic boundaries, or oceanic plates collide with continental plates, forming oceanic to continental boundaries. Or it can also be continental plates collide with each other, forming continental-continental boundaries. Let us start first with oceanic to oceanic boundaries. When two oceanic plates collide, the denser plate sinks below the lighter plate and eventually forms dark, heavy, basaltic volcanic island. As you can see in the illustration, one of the plates submerged under the other. Tsunami may be formed, earthquakes may happen. There is also subduction because one plate is denser than the other. When oceanic plates are subducted, they often bend, resulting in the formation of oceanic trench. Additional information, as you can see in the illustration, there is a what we call subduction, or it is the process by which a plate dives under a less dense plate. We also have here the concept of flux melting, or the process in which volatiles enters the mantle wedge, and the volatiles lower the melting temperature, causing volcanism. These illustrations show trench. Trench is a crack on the crust which is underwater. At many convergent plate boundaries, dense lithosphere melts or slide beneath less dense lithosphere in a process called subduction, and in that process, a trench is being created. Examples of ocean-to-ocean convergent zones are subduction of the Pacific Plate south of Alaska under the Philippine Plate, where it creates the Marianas Trench, which is known to be the deepest part of the ocean. We also have here a volcanic arc, another feature that is formed in an oceanic to oceanic convergence. A volcanic arc is a chain of volcanoes formed above a subducting plate, positioned in an arc shape as seen from above. Offshore volcanoes from islands, resulting in a volcanic island arc. An island volcanic arc forms in an ocean basin via ocean-to-ocean subduction. The Aleutian Islands off the coast of Alaska and the Lesser Antilles south of Puerto Rico are examples of island volcanic arcs. So let us move on to oceanic to continental boundaries. Oceanic plates are denser than continental plates, which means that they have a higher subduction potential. They are constantly being pulled into the mantle, where they are melted and recycled into new magma. The oldest oceanic plates are also the coldest, as they have moved away from heat sources such as divergent boundaries and hot spots. This makes them denser and more likely to subduct. So as you can see in the illustration, if an oceanic plate and continental plate collide, the oceanic plate will be the one to be submerged under the continental plate. Additional information for oceanic to continental boundaries, we have the term thrusting, or is the motion of pushing or lunging suddenly or violently. Sediment that has accumulated on the seafloor is thrust up into an accretionary wedge, and compression leads to thrusting within the continental plate. Accretionary wedge, it is a zone of deformed sediment made up of thrust slices scraped off or a subducting oceanic plate and added onto the overriding plate. So these are illustrations of other formation for oceanic to continental, just like the first type of convergent boundary, trench is also created. So when an oceanic crust converge or collide with a continental crust, a crack between the crust underwater called trench is formed. Another feature is this one, similar to our first category. Because a subduction continues, a group of volcanoes called the Volcanic Arc is formed at the surface of the continental crust along boundary where the two crusts converge. So just like what I've shown in the illustration, so as the oceanic crust converge with the continental crust, the oceanic crust subduct. And then there is a formation of volcanic arc on the surface of the continental crust. We have here also the continental to continental boundaries. So as you can see in the illustration, if two continental plates converge, so there is a formation of folded mountains or a chains of mountain. Continental to continental convergent boundaries pit large slabs of crust against each other. This results in a very little subduction, as most of the rock is too light to be carried very far down into dense mantle. Instead, the continental crust at these convergent boundaries gets folded, faulted, and thickened, forming great mountain chains of uplifted rock. So additional information, A continent-to-continent collision occurs when a continent or large island that has been moved along with subducting oceanic crust collide with another continent. Examples of continent-to-continent convergent boundaries are the collision of the India Plate with the Eurasian Plate, which creates the Himalaya Mountains. This illustration shows that the different features that are formed during a continental-to-continental convergence, and that is a mountain range. So converging continental crust or plates result in a collision zone, which could cause shallow earthquakes. At that place, a crack or cold fault is being formed. This type of convergence will cause no subduction, since the two plates have the same density. So that is the reason why. There would be no volcanoes formed, no tsunami. The convergence will result in a group of high landforms that we call the mountain ranges. Moving on to another type of plate boundary, we have the divergent plate boundary, wherein a divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, earthquakes are common and magma, or what we call as the molten rock, rises from the Earth's mantle to the surface, solidifying to create a new oceanic crust. Divergent plate boundaries mostly happen under the oceans. So let us discover the different features formed in divergent plate boundary. This is what we call as the Rift Valley, or a lowland region that forms where Earth's tectonic plates move apart or rift. Rift valleys are found both on land and at the bottom of the ocean, where they are created by the process of seafloor spreading. The most well-known rift valley on Earth is probably the so-called Great Rift Valley System, which stretches from the Middle East in the north to the Mozambique in the south. The area is geologically active and the features volcanoes, hot springs, geysers, and frequent earthquakes. Another feature is what we call as the mid-oceanic ridge or the oceanic ridge. As the plate move away, the gap between them increases. While this happens, materials from the mantle may rise, filling up the space. These materials pile up near the tension zone, forming mountain-like structures called oceanic ridges. But new material from the mantle may push the old ones. They filled up space between the plates and become a new seafloor. This process is known as a seafloor spreading. Now, the mid-ocean ridge is a continuous range of undersea volcanic mountains that encircles the globe almost entirely underwater. Let us move on to the last type of fault boundary, which is the transform fault boundary. It is mostly found in ocean, but there are few that traverse through the continental crust. This is characterized by plates moving horizontally against each other, producing a crack called fault on the ground. The force the plates exert can break the rocks and the other materials under the ground. The shaking usually ends abruptly. This is why it brings about strong earthquake. And when we talk about fault, we are referring to the fracture or zone of fractures between two blocks of rocks. So we have here the three types of fault. We have the normal fault, the reverse fault, and the strike slip fault. So as you can see, they are different depending upon on the location of the footwall block and the hanging wall, and its direction of transform fault boundary. A good example for the features under transform fault boundary is the San Andreas Fault. So San Andreas Fault is sliding boundary between the Pacific Plate and the North American Plate. It slices California in two from Cape Mendocino to the Mexican border. San Diego, Los Angeles, and Big Sur are on the Pacific Plate. Now, the hallmark of San Andreas Fault is different rocks on either side of it. Being about 28 million years old, rocks from the great distances have been juxtaposed against rocks from very different locations and origins. This So that ends our discussion for today, and these are the different references that I made use for our presentation. Thank you so much.